Very good evening, students. Welcome back to the another video of AI and machine learning series. So in this video, we are going to learn about logistic regression. In the earlier video, we learned about linear regression. So in this video, we will learn the logistic regression. So it is like a powerful method that help us to predict the probability. I will walk through the complete end-to-end machine learning pipeline using the Python and the dataset. We will cover everything from like data processing, like handling missing values and feature extraction to normalize the data, the mean and the standard deviation. Apart from that, what are the pipelines, because this is just an introductory video in the series of AI and machine learning, so we are just learning the thing. So for beginners, I have just normalized the thing. The pipelines are very easy for them, so that they can understand the things easily. So here in this the pipeline is like we are using the raw data set, feature extraction. Feature extraction in the sense I will tell to the machine learning model or like that ML that how or in which form the data are, how they are how they are in the .csv or whatever the format which we are using. And apart from that, we will use the bias addition, and then we will do the model training. In the last, we will do the evolution and the visualization using the graphical user interface. I have already developed a graphical user interface, but in this video I will show you that how you can create your own AI model or machine learning model. And like the training of if I say about or more something about how the training of the model will be done in this particular logistic regression, so I would say we have used the gradient descent to learn the best parameter theta. Bias term, so here we have add an intercept column manually, which helps our model to learn the baseline predictions. I remember you might know about the probability. So probability say about whether things are happening or whether things are not happening. Please don't say that probability can go in minus. No, probability will be always from between 0 and 1. So that's the approach which we are going to use. I will also use the sigmoid, so that the prediction will be in the between 0 to 1. Apart from that, what I say, I will also show you that what the mathematical formula I am going to execute on my Python code, so you can understand the things easily. Maybe I have here, yes, so these formulas I'm going to use. The bias term, which I say that we will use the column manually, which helps our model to learn the baseline prediction. So I will use this stack, I can say, yeah. And then sigmoid, which I already discussed. Thus this mathematical formula also we are going to use to say that how better the model are predicting from our raw data sets or to an unseen data. I will show you that how the things are going to work, and I will try to explain each and everything, even the mathematical things also. And apart from this, what I can discuss, yeah, in simple words, today we are going to build a logistic regression machine learning model, where we are going to take a raw data set. The data set will be in the form of the data is for RMS Titanic. It says that how many passengers boarded on RMS Titanic, and what were their age, whether they were male female, how much they were traveling with somebody or nobody. And in the last we will try to predict that whether that particular person, not that particular person, but that whether that similar person, having suppose if I give you the example, a person is age of 24 years, he was male, boarded on this particular place, and so on. And we will give the prediction that whether that person particularly survived or he died on that incident. So I will show you the data also, that how the data work. So this is the data which I already downloaded from internet. This is on the form.csv. So here thousands of samples are available, thousands of data are available with the name, but this is logistic regression, so we are not going to encode these names, because then it won't be worth it for the logistic regression. So we are just going to skip the name. We are just going to take the numbers. So if I say about the survive, means 0 stand for he died, 1 stand for survive. We will remove this name. For male and female, we will just denote them in the form of 0 and 1. And this is embarked, which is during the first RMS Titanic boarded the passenger from 3 different places. I don't know the name from where they boarded, but I remember that they boarded the passenger from 3 different places as given in the data set. So if I say just assume he boarded person from Southampton, maybe Q for Queensland, and C, I don't know, maybe somewhere in Europe, in France or in United Kingdom, maybe near English Channel. So yeah, the 3 places. We will also denote them in the form 0, 1, 2 or 1, 2, 3 maybe. Let's see. And yeah, this is how the pipeline will work. So let's start. So I will show you that how the thing's gonna work. So for me, I'm using the I will show you that I have already the things already with me. No, okay. Okay, so I will start here. Training of the model, I will write the code. After writing the code, we will execute the code, and we'll see that how the things work. Okay, so After the code, I will try to explain each and everything. So let's start. Maybe I will start with okay guys, so I think we are done with the coding part. I have completed the code. uh, there were some issue in the code, like there were some syntax errors I faced. So yeah, now I think I have compiled one time and it's working properly. So I will tell you that how the things are working. So I will show you that. So here are all the basic libraries: numpy, pandas, matplotlib for the plotting of the things, and then confusion matrix. So I will show that how the confusion matrix works. And then during the training of the model, I use that .csv, and like I just pre-process the data, like how the data are in which form. So I just did like I used just age embarked, that whether that the person or passenger boarded at RMS Titanic. Also classified that this S stand for 0, C stand for 1, Q stand for 2, and these all the classes which were there in the .csv here, like this p class, a male and female age is as civil parts fair embarked. And then we splitted the data in like training and validation. So here I will tell you like train, test, and split, which is already I have like imported from the library. It stands for test size equal to 0.2. So what does it mean? It means like out of 100 samples, 80 of the samples will be used for the training of the data, 20% of the data will be used for testing, means like unseen data, which the model will be used for the test during the testing, and it will predict whether that person belongs to that particular things, whether survive or not. So yeah, this 0.2 means 20%. We have normalized. That's I told you that mean and the standard deviation. We are saving the things on mean.npy and st.npy. The reason for using this is like during the scaling or like during the production, we can use this both things, and like we can enhance or we can like do the manipulation or like so on, like various of application have been done. We also added the bias, the intercept, an additional column, so that the pre-processing or like all the things for the training of the model will be done easily. And then the sigmoid, and then this formula which I told you, I shown you I think here. This formula I will show you here. This is this formula which has been used, so that it will say that how better the model is predicting from the data sets. And then gradient descent, sigmoid, all things. And then training theta, the things are being saved in the data files. I will show you the files also. And then yeah, evolution will be done. Also we have used the confusion matrix plots and so on things. I will show you during the compilation that how the things are working. So let's go. So I will also show you that like the thing that theta and the things which are being saved, so it will be saved here. Look, you can see that theta.npy train model.py, which we just wrote the code. So now I have already done the scripting, which I'm not going to show in this video, but I will show you the things that how the things gonna work. So this is like I just created an a testing. For testing, I just created a graphical user interface. So after testing the model or like deploying the model, we will run this script, and there will be a graphical user interface where we will put the things, and we will see that whether that person has been survived or not. So before going to this, let's compile our project. So we will go just we will go train model.py. So let's compile this. So you can see this model, like the training and the training accuracy and the validation accuracy, how the models are like being learned during the sets of data. And I will show you here also, like that the number of iterations have been done here, and that the you can say that's the prediction, or that the number of like percentage that how the model have been done. So you can see that the training accuracy is like around 80%, validation accuracy is like around 79%. Training accuracy stand for like that the seen data, that 80% of the data which have been used during the training of the model. So out of like 10, I can say 20 of the predictions or learning prediction is correct. 2 of them there is something like wrong. Similarly for the validation for the unseen data, because we are learning on the supervised machine learning model. So in supervised machine learning model, we have all the things in the labeled. So that's why that the validation accuracy of unseen data has been given like 79, which is not that very good, but yeah, it's still very good. Apart from this is the confusion matrix. I will show you the confusion matrix here also. You can see the confusion matrix, the number of like actual data and the predictive data. So this is like confusion matrix, and this is done. I think we will exit this. Now let's do the live prediction. So python, and there was live predict.py. Okay, now this is which I told you that I have developed a graphical user interface for it will be good for the user, like they can manually type the things, like suppose, so like say passenger class. So first is the first class passenger, second is second class, third class. So let's say I like anyone would be the passenger. So let's say he was a first class passenger, he was male or female, let's say male, or let's say female, okay, anything. Age 46 years old, anything. Sibling or spouses, maybe he can took the RMS Titanic, or he onboarded with her wife. So let's say wife, one wife. Parent child, maybe 2 daughters, anything. Fare, I don't know, maybe 500 euros, 5,000. Embark, maybe Queensland, we can say. Let's see whether that person has survived or not. So we will see here. So it's saying that with the accuracy of 96%, that prediction that person survived. Let's check another thing. Let's maybe person from third class, male, age same, siblings or spouse null, parents children, maybe he might be onboarded to the RMS Titanic with her daughter or son, maybe anything. Fare 45 euros, 45. Embark for maybe somewhere else. Did not survive. So yeah, this is like considered as a logistic regression. Logistic regression means like it will predict whether the things happen or not like or unlike a linear regression where it will go on the numerical form. So this is what we have learned today. Might be there's some issue. If you want something, I will also drop the notes. And because this is just an introductory video, so we have just used the simple things, we uses the simple form of logistic regression. If you want to see your like production ready logistic regression, so soon I will like upload my github, on my github, this logistic regression. That will be the enhanced version, production ready logistic regression model. And yeah, thank you so much for this.